To make BOE numerical questions, mathematical questions easy, in this video I am going to talk about the use of SI unit system, which is the most common unit system that is being asked in the BOE questions. In fact, if you see the various BOE questions, majority of in these questions, I have seen people are faltering in the units. Doing the questions answer correctly, but making some mistake in the unit ultimately leads to an absolutely wrong answer in their questions, and that is a very common difficulties I have seen, right? So in this video I'm going to talk about the use of SI units. I will give you some useful pointers to solve the numerical questions, various numerical questions. Those are coming in the BOE examination, right? Hello, my name is Anshuman Sen Sharma, and you are watching the official YouTube channel of indiaboiler.com, the boiler analyst. This is the BOE section. Now, the MKS unit of force is kgf. Of course, we do not write kgf, we write kg. Whenever the force unit is meant to be written in MKS, we write kg, but it actually is kgf. Now you might be wondering that I said that I will be talking about SI units, and then I have started with an MKS unit of force. Now let me tell you that the major problem is that some of the questions in BOE questions, you will find the data, the parameters are given in MKS system, right? And while solving, you have to convert it into SI system. And there are various ambiguities in MKS system. And the major ambiguities comes in the unit of force. And that is kgf, right? Now, what is 1 kg force, kgf force? It is the force with which an object with a mass of 1 kg is being pulled by the Earth's gravity towards the center of its Earth, right? So it's basically the gravitational force, or you can say it is the weight. Any object with a mass will have a weight, which is actually the force, gravitational force with which the Earth is pulling it, right? So now if I think about what is force, force can be calculated as the mass on which it is acting and the acceleration that it is creating by the product of mass and acceleration, right? So force can be calculated as mass into acceleration. Now when I say 1 kgf is the force, now which force is that? If I see the quantification of force, it is not there. It is the same as mass. So in MKS system, whatever is the value of mass is the value of force. But force is actually the mass into acceleration, and in this case, if I think about the gravitational force, that is weight, that is m into g. Now if 1 kg of force is there, that means the mass is 1 kg, right? And the gravitational acceleration g is 9.81 meter per second square. Now if you see the force unit, it actually comes to what? It comes to kg meter per second square. So 1 kg force, which is an MKS system, in terms of actual units, it is 9.81 kg meter per second square quantity of force, right? Now this kg meter per second square is the SI unit of force, right? Which is the correct unit. Mass into acceleration, kg into meter per second square. Now this kg meter per second square is not used. So what we use? We use Newton, right? So 1 kg force is 9.81 Newton, and this Newton is nothing but kg meter per second square. So if I see 1 Newton force, what is 1 Newton force? It is 1 kg meter per second square. So if it is acting upon an object with a mass of 1 kg, is going to implement or induce an acceleration of 1 meter per second square. So no ambiguities, right? So that is the advantage of SI unit. In fact, if I deal with SI unit, if I know the physical quantity, if I know the relationship between various physical quantities in a question, if a particular thing is being asked, the unit of which is known to me, right, I can actually look into the question and see what are the things that have been given, which if I multiply and divide, I can get the unit of the answer that they have asked, right? And that would be the solution. So that is the methodical process of SI unit. It has got no ambiguities at all, right? So let us deal with, let us say, pressure. Pressure unit, what is pressure? Pressure is force upon area. Now if you see the force unit in SI, it will be Newton, and the area will be meter square, right? So Newton per meter square will be the unit of pressure in SI unit. Again, Newton per meter square we do not use. We use it as Pascal, right? 1 kg per centimeter square. Now this is the unit which is most often being used in our workplace. In fact, in various BOE questions also you are going to find this kg per centimeter square. Now if I want to convert kg per centimeter square, kg I convert into Newton by multiplying 9.81. Centimeter square is 10 raised to minus 4 meter square, right? So that is ultimately coming to, when the 10 raised to minus 4 goes up, it becomes 10 raised to 4. So 9.81 into 10 raised to 4 Newton per meter square is 1 kg per centimeter square. Now this Newton per meter square is Pascal, so 9.81 into 10 raised to 4 Pascal is 1 kg per centimeter square. In fact, you can imagine the Pascal, the unit of pressure in SI Pascal is a very small unit, because 1 kg per centimeter square almost becomes 1 lakh Pascal, right? So what we do, we most often do not use Pascal, we use kilopascal, or we use another unit, that is bar, right? So to make it bar, what I do is 9.81 into 10 raised to 4, I make it 10 raised to 5. So it will become 0.981 into 10 raised to 5 Pascal. Why did I make it 10 raised to 5 Pascal? Because 10 raised to 5 Pascal is bar, right? So 1 kg per centimeter square becomes 0.981 bar. Now this is one of the most used conversion in BOE questions. More often than not, you are going to use this conversion. Pressure would be asked in kg per centimeter square, you need to convert it into bar. So you just multiply it by 0.981, you get bar, right? Now, you have another pressure unit, I would say, the way of expressing pressure, and that is by head, right? Now, when I say head, a head is H rho g. Now, H rho g, if I want to convert into the known unit of pressure, that is Pascal or kilopascal, as I said, 1000 Pascal or 1 kilonewton per meter square, then first of all, H is in meter, right? So the unit comes, H is meter multiplied by rho is in kg per meter cube, and the g is as an acceleration due to gravity, so meter per second square. Now what I do is, if I look at this unit, I do not make out anything. But when I just isolate this kg meter per second square, and as I have already told you that kg meter per second square is the unit of SI unit of force, which is expressed as Newton, then this becomes Newton meter per meter cube. So meter cube gets cancelled, it gets Newton per meter square, right? So that is how the head unit can be converted into SI unit, right? If it is a head of water, then the rho will be, you can assume 1000 kg, right? Whatever is the head is given in meter, you can take it in meter. G is 9.81 always, right? So that is how we convert the head into SI unit. Now, let us move on to another physical quantity, and that is work. Now, what is work? Work is force into displacement. Now, when I say unit, force unit is Newton, displacement unit is meter, so the unit becomes Newton per meter, Newton meter, right? So kg meter per second square, that is Newton into meter, kg meter square per second square, again kg meter per second square, I take it out, it becomes Newton. Newton meter is the unit of work. Now Newton meter again is expressed as Joule, right? This is known as Joule with a capital J. So in SI unit, any unit with a name of a scientist, right? Newton, Pascal, Joule, these are all to be written with a capital letter. Okay. Now, again, Joule is a very small unit, so most often than not we use kilojoule. Okay, 1 kilojoule is 1 kilonewton meter. Now, the advantage of SI unit, as I told you, that okay, kilonewton meter. If I think about kilonewton meter, I can get it in what way? So I can multiply kilonewton per meter square with meter cube, I get kilonewton meter, right? So when I get this unit kilonewton meter by multiplying kilonewton per meter square, which is a kilopascal, which is a pressure unit, with meter cube, which is a volume unit, I get kilojoule, right? So that tells us that the work can be calculated as pressure into volume, right? So most often PV, in BOE question, many a times you're going to see that PV is coming into the picture. So you know PV is nothing but the work part, right? When I multiply pressure into volume, I get work. The unit will be kilojoule or joule. If it is kilojoule, then P has to be in kilopascal, and V is always in meter cube, right? And that way. Okay. Now same way, if I just look at this question. This question has come in Chhattisgarh, right? And they are telling you there's a piston of an engine which is having an area of 0.0045 meters square. That is the cross-sectional area. It moves downwards 75 millimeters. So piston is moving 75 millimeters. It is displacing some amount of air. And whenever it is doing against a pressure, some work is done by the engine, right? Now, drawing in 0.00028 meter cube of fresh air from the atmosphere doesn't have any meaning, right? Wow, how much air it is bringing is not a problem, not a question. The question is how much air it is displacing, right? How much volume it is displacing. Now they are saying the pressure in the cylinder is uniform during the process at 80 kilopascal. So the pressure is given in kilopascal, while the atmospheric pressure is 101.325 kilopascal. Again, it has got no relevance to this question, because they are saying the difference being due to the flow resistance in the induction pipe and the inlet valve. Now, whenever you see a question in BOE, the first thing you see what they are asking, right? So they are asking work done by the air, right? Displacement work done by the air. So in this case, we have to find the work done. We need to find, okay, what was the pressure and against what pressure, how much is the volumetric displacement that has taken place, right? So in this question, the displacement is given in millimeter, that is 75 millimeter comes to 0.075 meter, and the volume, that is the displaced volume, is the cross-sectional area into the displacement, right? So that comes to 3.375 into 10 to minus 4 meter cube. We know that it's a constant pressure, the uniform pressure 80 kilopascal during the expansion process, right? So we just multiply the pressure into volume, we get the work done, right? It was a very, very simple question. Looking at the question, you might get confused because a lot many irrelevant data are added, and that is happening in BOE question many a times you are going to see. Okay, moving on to the another use, which is quite often we have to be careful, because whenever see we kilojoule. Now can be seen in the specific heat, in the gas constant, right? And when we use the gas constant in this universal gas equation, or I call it characteristics gas equation, using the characteristics gas constant. In fact, one tip, that whenever in a BOE question you see gas constant it is given, you understand PV is equal to MRST has to be used. Now what is the unit of RS? The specific gas constant or characteristic gas constant, the unit is kilojoule per kg Kelvin, right? Now kilojoule per kg Kelvin, if you see, then if I just want to find out, okay, how the RS can be expressed, so from PV is equal to MRST, I can say RS is equal to PV by MT, right? Now PV goes to the kilojoule part, MT is the kg Kelvin, because mass is given in kg, temperature is in Kelvin. So in that case, we understand pressure in this has to be kilopascal. So whenever we use PV is equal to MRST, please remember the pressure unit has to be kilopascal, because the specific gas constant unit is kilojoule per kg Kelvin. Okay, this is a very important thing to remember, and the temperature will be in Kelvin, volume in meter cube, temperature in Kelvin. Okay, now this is the question, another question which I have shown earlier. This is the question which I have already solved in my previous video, right? But I just wanted to connect that if you are thorough about the units, you do not make any mistake, right? So here you can see they have mentioned that the gas constant of air and flue gas. As I told you, whenever the gas constant is mentioned, that means PV is equal to MRST will be used. Okay. In this question, how did we use it? So PV is equal to MRST we used to find out the density. M by V is equal to P by RST, right? Now what you need to be careful about the units. The pressure has to be in kilopascal. See here, the pressure of the air is given atmospheric pressure in mmHg. Okay, then they have given the gas pressure. You can calculate the gas pressure by the draft, which is nothing but the delta P, right? Difference between the air pressure and the gas pressure, and that they have given you 18 mm of water column, right? So different pressure units have been given, but ultimately the pressure which you need to find out is 760 mm of mercury in terms of kilopascal, 760 mm of mercury minus 18 mm WC, which will be the pressure of the gas, again in terms of kilopascal. Then only you can use it in this M by V is equal to P by RST to find out the density of the gas and air, which you need to answer this question in kg per meter cube, right? So that is something I just wanted you to focus on. Okay, now power. Now what is power? Power is either work by time or energy by time, rate of energy or rate of work done. Now work we know is kilonewton meter, right? So work is kilojoule per second, work is kilonewton meter, and the unit of power becomes kilojoule per second. Time will be always second. Now again, kilojoule per second is called the kilowatt. Joule per second is watt. So kilojoule per second is kilowatt. Again, I am breaking this kilojoule per second. Kilojoule per second is kilonewton meter per second, right? Now kilonewton meter per second can be calculated as kilonewton per meter square into meter cube per second. Now this kilonewton per meter square is kilopascal, so that is basically the pressure, and meter cube per second is the volumetric flow. So when you multiply pressure with volumetric flow, you get power. I have shown you earlier, work can be calculated as multiplication of pressure into volume. When I can multiply pressure into volumetric flow, I get power. Now where it is used? It is used in finding out the power of fans and pumps and BOE questions, right? So the discharge power, which is known as the hydraulic power of a pump or a fan, if you want to calculate, all you need is the discharge pressure against which it is creating the flow and the volumetric flow. But again, if I want the power in kilowatt, the pressure has to be in kilopascal and the discharge or volumetric flow should be in meter cube per second, right? So again, I refer back to the third question I have given here. This question has come in Gujarat BOE. Now what they have given at the pump is delivering 40 meter cube per hour of water with a discharge pressure of 29 meter. Now they have given this pressure in head. 29 meter means 29 meter of water column. The water is drawn from a sump where the level is 6 meter below the pump center line. So the pump is sucking the water from a level which is below the pump center line, 6 meter below the pump center line, and they are asking you to calculate the pump efficiency, but they have given you the power drawn by the motor as 7.5 kilowatt and the efficiency of the motor is 89%. Now to answer this question you need to know basic few things. One is that the pump efficiency is nothing but the output by input of pump. Output power is called the hydraulic power. Input power is the power given by the motor to the shaft of the pump, right? That is called shaft power. So efficiency of a pump can be calculated as hydraulic power by shaft power, and shaft power is nothing but the power given by the motor, so that would depend on how much power it is drawing and its efficiency, right? So the shaft power is equal to motor power divided by motor efficiency. These are the two basic things you need to know. The third thing you need to know is that whenever the suction is below the pump center line, right, that means the pump has to first pull this and then push it against the discharge pressure of 29 meter in this case, right? So the net discharge pressure will become the suction head plus the discharge head, because the suction is negative, so it has to be added. This is something we need to know to calculate this, answer this question. Okay, so in this particular question the net discharge pressure will become 29 plus 6, so that is 35 meter, and we need this shaft power is given in kilowatts, so we need the hydraulic power, which is nothing but the volumetric flow into the pressure, and that pressure has to be in kilopascal if I need the hydraulic power in kilowatt. And since the the shaft power is given in kilowatt, it has to be calculated in kilowatt, right? So this has to be changed into kilopascal. Now 35 meter again is the head. I have already shown H rho G. H rho G will come in Pascal, so I have to multiply 10 raised to minus 3, right? So assuming the density of water, now this is another point, that in this question the density of water is not mentioned. You can assume 1000 kg per meter cube, but in that case you need to write assuming the density of water as 1000 kg per meter cube. The head, 35 meter head, will become H rho G into 10 raised to minus 3 kilopascal, so that comes to 343.35 kilopascal, right? Now the volumetric discharge is given in 40 meter cube per hour. That means 40 by 3600 meter cube per second, right? The hydraulic power, that means the output power of the pump, will be the pressure into the volumetric flow, right? The shaft power will be the motor power divided by the efficiency, which is 7.5 divided by 0.89 kilowatt. So the efficiency of the pump can be calculated as the hydraulic power into volumetric discharge divided by the shaft power. Now you have noticed one thing, you should notice one thing, that I have not calculated 40 by 3600. I have not calculated 7.5 by 0.89, right? I have not calculated the hydraulic power as 343.35 into 40 by 3600. I have done this calculation at the end. Now this is another thing I have given in the numerical tips, that do not use the calculator in every step. Use it in the final step. Use the brackets. The way I have written it, you can write it. You can use the brackets because your calculator is having the bracket function. You can use the bracket and get the answer. The answer will come to 0.4527, that is 45.27%, right? So this is certain things you need to remember when you answer the BOE questions. Similar things I am going to share whenever the time comes, right? There are small snippets of videos I'm going to create. Just keep on watching and keep on just getting the notification. If you subscribe, you're going to get the notification, right? And you will get some such short videos from me from time to time. Okay, thank you and bye bye.